Hello class, we're going to do some mole conversions as we progress here through the unit. And so the mole is all about quantifying things, trying to figure out, how many atoms are in a sample, so that way when we get into stoichiometry we can figure out how much of a product we can make in a reaction, or how much of different reactants we need to make a certain amount of a product. So mole conversion, so if we have 1 mole, we're going to continue working with copper here. Alright, so 1 mole of copper, if we have a mole of it, we know two things. So one thing we know is that if we have 1 mole of copper, we have 6.02 times 10 to the 23rd atoms of it. The other thing is we can look at the periodic table and we know how much the molar mass is. So we know how much that mole would weigh. And once again, rounding to the hundredths place, since that's where our scales measure to, we would get that there's 63.55 grams of copper. Alright, so we know two things. If we have 1 mole of copper, we know how many of it, how many particles we have of it. We also know how many grams its mass would be. So often in class we'll weigh out a sample in grams, and then we want to quantify it. We want to figure out, if I have, let's say I have 10 grams of copper. I would want to know how many atoms of copper I have in it. But the thing is, I can't jump from this directly into this. I always have to go through the mole. And so there's two algebraic triangles here that we can learn. I'll give you a flow chart in class too, but you can look at the flow chart. I'd like you to use the triangle here. And here's one triangle. So mass, if you know how many grams you have, so if you put an object on a scale and the scale says you have 10 grams of copper, what do you do with that? Well, if mass divided by the molar mass, how much 1 mole weighs, will give you the number of moles, which you use little letter n to represent. So let's see how we set this up with dimensional analysis. So if you have 10 grams of copper, using dimensional analysis we like to put our starting quantity over 1 to show that the 10 grams is the numerator, and the conversion factor is 1 mole is equal to 63.55 grams. So this is our conversion factor. So one part goes on top, one part goes on the bottom. Well, the beautiful thing is, whatever goes on top, whatever unit's on top here, that same unit will appear in the bottom over here because we have to cancel out of that. So the mole part, 1 mole of copper, will go on top. The mass, what it's equivalent to, goes on the bottom. And so we get 63.55 grams. So moles are converted like this. So you take the mass, 10 grams, essentially divide it by how much the molar mass is, and that'll give you the number of moles. And thinking sig figs here, let me pull out my calculator. So we're going to take 10, which has 4 sig figs, divided by 63.55. And what we get is this. We get 0.15735, and so we're going to round that to 4. 1.1574 units. Grams of copper cancel, and we're left with moles of copper, which are, remember, collections of 602 sextillions. So we have 0.1574 collections of 6.02 times 10 to the 23rd copper atoms. Well, what does that mean? Well, we can use our next triangle to put that into numbers. So our next triangle, if we take the number of moles and multiply it by how many of something are in a mole, 6.02 times 10 to the 23rd, that'll give us the number of particles. So that's what we're going to do. We're going to take our answer from last part. We're going to take 0.1574 moles of copper, put it over 1. What do we know? Our conversion factor. The conversion factor is 1 mole is equal to 6.02 times 10 to the 23rd. So the mole part of our conversion factor goes on the bottom so that the units of copper, moles of copper, cancel. Put 6.02 times 10 to the 23rd up top. So this times this. And we only can keep 3 sig figs here since Avogadro's number only has 3 sig figs, at least the one that we're using. So I'm doing this. And we get as an answer 9.475 times 10 to the 22nd atoms of copper. And so looking at this, we can keep 3 sig figs because this has 3 sig figs. So because the first number we're going to chop is 5 or higher, we round the next number up. So 7 rounds to 8. Alright, so that's 2 one-step problems. If we do a 2-step problem, if we, let's say, have 15 grams of water, how many molecules of water would we have? So 15 grams, convert that into molecules. So first step, take what we know, 15 grams of water. We're going to put that over 1. We have to convert into moles first. So mass divided by molar mass gives you number of moles. So 1 mole of water weighs how much? Well, 2 hydrogens at 1.01 each is 2.02 plus the 16 grams of oxygen. So 2.02 plus 16 is 18.02 grams. So grams of water, they cancel. So now we're in moles of water. And we just established that if you know the number of moles, moles times Avogadro's number will give you the number of molecules. So moles of water cancel. So let's go ahead and get our calculator out. Once again, 3 sig figs, so 15 divided by 18 times 6.02 times 10 to the 23rd. And we get 5.016, so 5.02 times 10 to the 23rd molecules of water. Alright, so that makes sense. Think about it. 1 mole weighs 18.02 grams. We have 15 grams, so we have roughly 5/6 of a mole. And so in 1 mole, there's 6.02 times 10 to the 23rd molecules. So we have 5/6 of that amount. And so 5.02 is roughly 5/6, so 6.02 times 10 to the 23rd. Alright, hope it helps. We're going to do some more advanced ones next. I'm going to end this tutorial right now since it's up to 8 minutes. Thanks for paying attention, and come back for more harder problems.